Alright, so now we're going to start with number 10. So here I would subtract 25. We'd have 9x squared equals negative 25. Divide by 9, so x squared equals negative 25 over 9. And then we want to take the square root of both sides, so we just get x. So when I take the square root of negative 25, well, that's going to be plus or minus 5i. And the square root of 9 is 3. So my answer is going to be plus or minus 5i over 3. All right, let's move on to number 11. The percent of people at a certain age x that cause an accident in the United States can be found by this equation, where x represents their age and the f of x is the percentage of accidents that those people cause. So this is going to be a parabola that opens up. It's going to be really wide. It's going to look something like this. We want to, but what we want to do is find the number of people, or the age of the people that cause the least amount of accidents. So that's going to be the age x, and the percent of those people that cause accidents. The percentage of those people that cause the accidents is going to be y. So that means we want to find the vertex. So what we're going to do, we can actually plug this into our calculator and find the the minimum point that way, or we can just do negative b over 2a. So negative b is going to be positive 0.84 over 2 times a. Well, that's 0.02. Well, that's 0.84 divided by 0.02, which is 42, which means 42-year-olds are going to cause the least amount of accidents. And then if I plug 42 in for x here, I can use my calculator. That's going to end up being 7.36 for y. So 42-year-olds, 7.36% of 42-year-olds will cause an accident. I don't know if that's true or not. I just kind of made that up, but that's what the answer to this question would be. And we could do that on our calculator by finding the minimum point as well. So let's move on to 12, 13, and 14. So here are the operations with complex numbers. And so what we're going to do for number 12, we have 7 plus 2i. There's like a negative 1 here. I'm going to distribute that negative 1. So this is going to be negative 8 and then plus 5i, because negative 1 times negative 5i is positive 5i. Well, 7 minus 8, that's negative 1. 2i plus 5i is 7i. And that's in a plus bi form. 13, we're going to have to distribute. 3 times 6 is 18. 3 times negative 3i is negative 9i. 5i times 6 is 30i. And 5i times negative 3i is going to be negative 15i squared. But I squared is negative 1. So this is actually going to be positive 15, because it's negative 15 times negative 1. 18 plus 15 is 33. And then negative 9 and positive 30 is negative, or is positive 21i. And then number 14 is very similar to number 13. We're just going to take 4i minus 3 times itself. 4i minus 3. So 4 times 4 is 16. 4 times negative 3i is negative 12i. Then 3i times negative 3i times 4 is another negative 12i. And negative 3i times negative 3i is positive 9i squared. Well, this is negative 9, because it's 9 times negative 1. And 16 minus 9 is 7. And then negative 12i and negative 12i is negative 24i. Or negative 24i. Yeah, so 7 minus 24i. And then the last one on this part of the test is number 15. And here we're supposed to find the absolute value of this complex number. Well, if I were to graph it first, it would look something like this. In the real direction, we're going to go out to 12. And in the imaginary direction, we're going to go down 5. Which means this distance is 12 and this distance is 5. But I've got to find the diagonal distance. So I'm going to use, because the absolute value means how far away from 0 it is. So I'm going to use the Pythagorean theorem. 12 squared plus 5 squared equals, let's call this c squared. And that's 144 plus 25, which is 169, equals c squared. And if I take the square root of both sides, that's exactly 13. So that's the first part of the test. That was where you could use a calculator. And then the last two questions were all on graphing. And so let's just see if we can go through and do these graphing equations. First thing I want to do is find the vertex. So I'm going to use negative b over 2a. Here we don't have a calculator, so we just have to do it by hand. So that's going to be negative 4 over 2 times negative 1. Well, that's negative 4 over negative 2, which is 2. So the vertex is at the point 2 something. That also means that my axis of symmetry is at x equals 2. Well, how far up or how far down is the vertex? Well, that means I'm going to have to plug 2 into my equation. So I'll have 2 squared, which is 4. This is going to be negative 4. 4 times 2 is 8, and then minus 1. That's going to be 4 minus 1, which is 3. So the vertex is at the point 2, 3, which is, make sure I get this right here. And then because the a value is negative 1, normally I go over 1 and up 1, but now I'm going to go over 1 and down 1 in both directions. Normally I go over 2 and up 4, but now I'm going to go over 2 and down 4 in both directions. And my parabola looks something like this. Y-intercept is right here at the point 0, negative 1. So there's the first one. And then that's in standard form. The next one that we're going to do is in vertex form, which should make it a little bit easier because in vertex form they actually give you the vertex. The vertex is at the point 1, negative 3. 1, negative 3. So I'm going to go over 1, negative 3, which is right here. Okay, you can think of it also as shifting it 1 unit to the right and 3 units down. But now the a value is 2. So normally from the vertex I go over 1 and up 1, but now I'm going to go over 1 and up 2 in both directions. Normally I go over 2 and up 4, but now I'm going to go up twice that. So I'm going to go over 2 and up 8 in both directions. It's a skinnier parabola. It does open up. It looks something like this. And the axis of symmetry is going to be at the point x equals 1 because it's right along the, it's where x is equal to 1. It's a vertical line there. And the y-intercept is the point 0, negative 1. And there's our quiz. Hopefully this video helped as you made corrections on this. Remember, your corrections and your correction sheet are due Friday. We will see you soon.